So the last method we're going to talk about today is called elimination. And it's basically like we're going to take the two equations and we're going to either add them together or subtract them to make one equation so that we can solve. So this is my personal favorite. I like this one the best. It just always made the most sense to me. I liked the way it worked out together and how it kind of just simplified it right off the bat instead of having different steps. But before we do that, I just wanted to look at 3 different examples with you so we can talk about which method would be the best approach or the fastest approach based on the way that the system is given to us. So if you look at that first green box, it gives us y equals negative 2x plus 5 and y equals 4x minus 1. They're both in y equals mx plus b form. Those graphs are easy for us to pick out the slope. It's easy for us to pick out the y-intercepts for both of these. So that would be a good system for us to graph because we're talking about they're both y equals mx plus b, which is good for graphing. So when you get 2 equations or they give you a system where both of them are y equals, your best method is probably going to be graphing. It's going to be your fastest or your easiest method at that point because it's easy for us to identify the slope. It's easy for us to pick out the y-intercept, so we want to graph them, see where they intersect. That middle system, the y equals negative 2x minus 9 and the 6x minus 5, there should be a y here, equals negative 19. That equation, those equations aren't really set up for us to graph because they're not both in y equals. The top one is, but the bottom one, if I tried to get that in y equals, I'm going to end up with decimals, I'm going to end up with fractions. Not the greatest numbers for me to graph and try to get an accurate picture of in order to get a solution. So when I have situations where maybe one of them is easy to graph but the other one isn't, that's something that I want to use substitution for because I already have my y all by itself. So those are like our favorable substitution situations. So if here, because one variable is alone good for substitution. First one was good for graphing. Now, if you look at that last one, x and y are both on the same side for both equations. And we even see that our x's have the same coefficients, our y's have opposite coefficients, but we've got the same number, just opposite signs there. Those are our situations where elimination works out the best because we're going to be able to eliminate a variable right off the bat when we add those equations together. So when we have x and y on the same side and they have very similar coefficients, that's when we want to use elimination. Now, you wouldn't be wrong if you chose to manipulate the equations and rewrite them so that you could use your preferred method. It's just faster and more efficient if you can recognize what kind of situation they're giving you and which method would be the best one to use. It just helps you solve them quicker with less steps. So now that we know that elimination equations have our x and y's on the same side, they also have very similar coefficients. Let's talk about what we have to do in order to solve by elimination, and then we'll actually solve one. Okay. So if we're going to solve by elimination, the first thing we want to do is decide which variable we want to eliminate. So decide, do we want to get rid of x or do we want to get rid of y? So your first step, decide if you want to eliminate x or y. And the way you're going to decide this is if you have a variable that has the opposite coefficients already. So like if I look back at that third example up there where I have 3x plus 2y equals -4, and then I have 3x minus 2y equals -4. Since I have a positive 2y and a negative 2y, the easiest thing for me to eliminate there is the y's because they're opposites. So your first choice is going to be eliminate the variable with opposite coefficients. And opposite coefficients means it's the same number, but the signs are opposite. Because we know a positive 2 and a -2 cancel each other out, they can go away. So I don't have to change anything in that in order to eliminate that variable. If they don't have opposite coefficients right away, if they have the same coefficient, that would be our second option because we could easily multiply by a negative and make them all an opposite if we needed to. So if they don't have opposite coefficients, your next choice is eliminate the variable with the same coefficients and then a very last resort, if you don't have opposite coefficients or you don't have the same coefficients, you're going to have to decide what you want to multiply by in order to get those coefficients to be opposites. So you might have to multiply one equation in order to make opposite coefficients. And we'll look at an example of each one of those so that you know what they look like, so you know how to do that. Once we decide which variable we want to cancel out, we're going to add or subtract the two equations to make one big equation. So next, add or subtract the equations to make one equation. And at this point, once you add or subtract these equations and get to just one equation instead of two, your new equation should only have one variable in it. Because the whole point was we wanted to eliminate one of the variables, so we should only be left with one variable. So we want to add or subtract the equations to make one equation with one variable. We're going to solve that equation, get our answer, and then just like with substitution, plug our answer back into one of the equations to get the other variable. So we're going to solve and use answer to find the other variable. First, we're going to look at it. We're going to say, okay, should we get rid of x or should we get rid of y? Once we decide, we're going to add the equations together or subtract them to get one equation, solve that equation. Once we get an answer for the variable, we're going to plug back in to get the answer for the other variable. So if we're looking at an actual example, it would say something like, use elimination to solve 3x plus 2y equals 4 and 3x minus 2y equals negative 4. First thing we want to do is we want to look at that and say, okay, do any of my variables have opposite coefficients? Do any of them have the same number but opposite signs? And I see right off the bat when I look at this that I have a positive 2y and a negative 2y. So that's best case scenario. This is the nicest it's going to work out for us, that we can just add these equations together just the way they are. The y's are going to cancel out. So we want to get rid of our y's. In order to do that, I am actually just going to add the equations together as if it was a big addition problem like back in the day when you would add like 364 and 529 and you would just go straight down and add the numbers up. So I'm going to say, okay, 3x plus 3x gives me 6x. 2y minus 2y, I know is going to cancel out. I'm going to bring down my equal sign. And I'm going to go 4 minus 4 gives me 0. So now all I really have to solve is this 6x equals 0, which is a much easier equation for me to solve than two equations with different variables. So after I add them together, now I just need to solve for x here. So I've got to get rid of that 6. So I divide by 6 on both sides. I end up with x equals 0 divided by 6 is just 0. So now I've got x equals 0. I've got to use my answer in order to find my y value. So now at this point I can pick either equation. I can use my top one, I can use my bottom one. It's completely up to you which one you use. And I'm going to plug my x value back in and find my y value. So where I had x, I'm going to replace my x with a 0 since I know that x is 0. So I'm going to say 3 times 0 plus 2y equals 4. And I'm going to solve for y, so 3 times 0 gives me 0. So I have 2y equals 4. I divide by 2. And I get y equals 2. So once I have an x and I have a y, then I'm done solving that. So I eliminate one of the variables. Once I solve that simplified equation, I plug my answer back into one of the equations and solve for the other variable. if we were going to solve 2x plus 2y equals 4, and 2x plus 7y equals 9, I don't have anything that's already opposite coefficients, but I do have a variable that has at least the same number in it. I see that right off the bat. I see I have a 2x and I have another 2x. So in this situation, I want to eliminate my x's because they are the closest thing to having opposite coefficients as I can find. My y's have a 2 and a 7 in front of them. Not very similar. I don't want to pick y. So in order for me to do this, I need to make them opposite. So I'm going to change the sign to a negative. But when I do that, I have to change the sign of every single term in that equation. So the 2x becomes negative, the 7y becomes negative, and the 9 becomes negative. So I have to make sure when I do that that I put a negative in front of everything. It's also like saying I was subtracting the equations instead of adding them. Once I do that, now I can eliminate, because 2x minus 2x is going to cancel out. 2y minus 7y is going to give me negative 5y. And 4 minus 9 is going to give me negative 5. So now I got to get y by itself. So I'm going to divide by negative 5 on both sides. And I get y equals 1. So now that I know my y value, I'm going to pick one of my equations to plug back into and solve for x. I'm going to take the top equation, 2x plus 2y equals 4. I only picked the top equation because I like the numbers 2, 2, and 4 better than I like working with 7 and 9. They're just smaller, it's easier to multiply. But I can use either equation. Then I'm going to go in and my 2x plus 2. I'm going to replace my y with a 1. And I'm going to simplify so that I get 2x plus 2 times 1 is 2 equals 4. Subtract 2 on both sides. And I get 2x equals 2. So then I divide by 2 on both sides. And I get x equals 1. So I've got an x, I've got a y, I'm done solving. Now this last one we want to look at, you'll notice right away I have a negative 10x, a positive 3y, a negative 5x, and a negative 6y. So I don't have anything that has the same number in front of it. They're all different, right? I have a 10 and a 5, and then a 3 and a 6. So I have to actually multiply one of these equations. I have to manipulate it so that it has the same numbers. So I have two options. I notice right away, negative 5 I can multiply by 2 and get negative 10. Or 3 I can multiply by 2 and get 6. I want to decide, do I want to multiply and get rid of my x's, or do I want to multiply and get rid of my y's? Since my y's have opposite signs already, I'm going to decide to cancel out my y's, because that means I don't have to multiply by a negative number. I can multiply by a positive number because I don't need to change the signs for anything. So I want to multiply my top equation by 2, because if I multiply it by 2, 3 times 2 gives me 6. and then I would have a 6 and a negative 6 for my y's, and they would cancel out. So when I multiply by 2, I have to multiply every single term by 2. So that means my new equation is going to end up being negative 20x, because 2 times negative 10 gives me negative 20. Then 2 times 3y is going to give me positive 6y equals 2 times 1, which is 2. I'm just going to rewrite my bottom equation exactly the way it was. I had a negative 5x, a negative 6y equals 23. And now, because I have a positive 6y and a negative 6y, I can combine, or I can eliminate my y's. They're going to go away because they're opposites of each other. When I add these equations together, negative 20x minus 5x is going to give me negative 25x. Bring down my equal sign. 2 plus 23 is 25. And then divide by negative 25 on both sides. And I get x equals negative 1. Now that I know that x equals negative 1, I want to take one of my equations, plug in negative 1, and solve for y. I'm going to take my top equation, negative 10x plus 3y equals 1, where I had an x, I'm going to replace it with a negative 1, so I end up with negative 10 times negative 1 plus 3y equals 1. Negative 10 times negative 1 gives me 10, plus 3y equals 1. I've got to get y by itself, so I'm going to move the 10. So I have 3y equals 1 minus 10 is negative 9. Divide by 3. And I get y equals negative 3. If I wasn't sure that my answers were correct, I could always go back, plug in my x value, plug in my y value to one of the equations, and see if it made it true. Remember when we first started talking about this and we were checking to see if points actually worked as solutions? So if for some reason you were just like feeling a little bit uneasy about solving it, or you weren't sure if it was the correct answer, you could always go back and check yourself by plugging in your x value, plugging in your y value, and seeing if it made the equation true.